All right, let's jump right in. Today, we're exploring a really fascinating connection: how artificial intelligence is changing, well, the very ground beneath our feet, and the world we're building right on top of it. I mean, just think about that for a second. What if the ground could actually tell us its secrets, point out its weaknesses, warn us before it fails, and help us build things that are safer and stronger than ever before? It sounds like something out of a sci-fi movie, but believe it or not, it's happening right now. This is all about the fusion of AI with geotechnical engineering. The very foundation of all our infrastructure. We're talking about building a smarter world, and yeah, we mean that quite literally, from the ground up. Okay, so to really get a handle on how this amazing partnership works, we first need to understand the two different fields that are coming together here. Two worlds, but they're aiming for the exact same goal. So first up, you've got geotechnical engineering. The easiest way to think about it is like this. It's basically being a doctor for the ground. Its whole job is to understand the soil, the rock, everything that our buildings and bridges and tunnels stand on, just to make sure that foundation is absolutely solid. And then, on the other side, you have machine learning, which is a key part of AI. So if geotechnical engineering is the doctor, well, machine learning is the superpowered brain we're giving that doctor. It's this incredible ability for a computer to just sift through mountains of data, find patterns that we would never see, and make predictions all by itself. And that right there is the fundamental shift. I mean, the old way, you'd take a few soil samples here and there, a handful of data points, and then do a bunch of manual calculations. The new way, it's a total game changer. It uses machine learning to analyze vast data sets, geological surveys, lab tests, you name it, to see the entire picture and make predictions that are just incredibly insightful. So, that's the big idea. But how does this actually work in the real world? Let's take a look at some of the practical applications where this combination is already making a huge difference. For starters, predicting how soil is going to behave. Machine learning algorithms can look at satellite data, seismic sensor readings, and old borehole logs to figure out exactly what kind of soil we're dealing with. But here's the really cool part. They can then predict how that specific soil will act under stress, like how it might liquefy during an earthquake, or how much it's going to settle under the crushing weight of a new skyscraper. Then there's the whole hazard forecasting side of things. It's basically a super powerful early warning system. By looking at historical landslide data, an AI model can flag slopes that are at a high risk of failing. That lets us go in and build retaining walls or better drainage systems to stop a disaster before it starts. It can even model how contaminants might spread through groundwater, which is incredible for stopping environmental damage. And this brings us to what might be my favorite part: proactive maintenance. Our big structures, our bridges, dams, and tunnels, they can be loaded up with all kinds of sensors. Things like inclinometers measuring tiny shifts in tilt, or piezometers tracking water pressure. Machine learning just watches that flow of data 24/7, and it can spot tiny little anomalies that could signal a major failure down the road. It lets us fix problems long before they become catastrophes. Now, all of this sounds pretty incredible. And it is. The potential here is just enormous. But, like with any groundbreaking new technology, the path forward isn't exactly a walk in the park. There are definitely some challenges. Yeah, it's really a balancing act. On one side, the benefits are obvious, right? Better risk management, serious cost savings, and much more sustainable designs. But the biggest hurdle, the real roadblock, is the data itself. Geotechnical data is often scattered, it's inconsistent, and to properly train these powerful AI models, you need a ton of high-quality, standardized data. That's a huge challenge the whole industry is working on right now. So, to make all this a little less abstract, let's look at a real-world example of this tech in action. There's a system called Daarwin, and it gives us a fantastic glimpse into what this whole workflow looks like today, turning all that raw data into safer, better-built structures. And the process, it's really logical. First, it just pulls in and digitizes all the available ground information. Then it creates this clear visual model of what's happening beneath the surface. But the real magic happens in step 3, where it uses AI to analyze just countless different design scenarios. And finally, it helps engineers pick the absolute best design, and then keeps an eye on the project during construction to make sure everything's on track. So, when you kind of step back from the technical details and you look at the big picture, it becomes really clear. This isn't just a small improvement. This is about completely reshaping the future of how we build our entire world.
At the end of the day, that's why this is so important. The goal isn't just to have smarter technology for its own sake. It's about using that tech to build a world that is fundamentally safer, way more efficient with our resources, and much more sustainable for all of us.
This quote really just says it all, doesn't it? This partnership truly has the potential to drive sustainable development and to make our infrastructure more resilient, not just in one place, but all across the globe. And that really just leaves us with one last question to chew on. Right now, we are teaching our machines to understand the very ground we stand on. So as our ambitions get bigger, as we build higher and smarter, what other fundamental truths about our world will we need to teach our AI partners to help us build the future?